Hi, and welcome to my Pony Twitch stream for February 6th, 2019. I'm Andrew Turley, and hopefully this is all working. We don't have technical difficulties like we did last time. Things seem to be stable for now, so great. So I'm going to keep talking about Pony's C FFI. Last time we started looking at it and we went over some of the basics, how to use structs, how to pass simple types back and forth between C and Pony, things like that. So this time I want to spend a little bit more time talking about things like talking about some other ways of passing data around and talking about callbacks. So let's start by looking at the code that we have so far. So this is a basically a C library that I've created. It has some functions and structure, and we can also look at the Pony code that uses this library. So we have some places here where, first of all, we use have a use directive up here at the top that tells us to use this thing and tells us that it's a library. Then we have these use statements here, which are the way that you tell Pony ahead of time what the type signatures are of the functions that are available in the library. And so inside the square brackets at the beginning here is the return type. And then in the parentheses, these are the arguments that you can pass to the functions. So if we look at our C program, we can see that we've got this function called mine that returns an int and takes an int as an argument. And so up here we've got this thing that says that basically says the same thing in a way that Pony can understand. And then we have this struct here in C that has one field called x. So we have an equivalent struct over here in Pony, and that lets us get the return value from getStruct. This getStruct thing that returns a pointer to the struct. And makes it so that we can access the value that was returned. So that's kind of an overview of what happened last time. So let's move on. The next thing I want to show is there's another way to actually work with structs, and it's been a little while since I've done this, but so if you don't want to return a pointer to a struct, you can actually use tuples in Pony to describe the structure of a struct and get it back and work with it. So we're gonna do this. I'm just going to call this function getStruct copy. So since we're not returning a pointer, we're actually going to get a copy of this thing back. Now you're going to get to watch as I'm rusty and I try to remember how to do a struct literal in C. Is that going to do it? Probably not. One second. There we go. All right, I see is rusty. Okay, so this should create a struct and return it. So let's create a declaration up here that tells Pony how to use this function. So we should be able to pass a tuple back, or we should be able to tell it that this thing is a tuple, and it should be able to interact with it in Pony like a tuple. So git struct copy. So now let's say MSC equals git struct copy, and then so that this underscore, so we've got MSC, which should be a tuple with one value. So underscore 1 will get us that value back, and that value is going to be an I32, so we need to call the string method on it. Okay. Let's actually change this just to return a different value than the other function, just so that we can kind of see a little more easily what's going on. All right. So we're going to come back over here, build it again, build our library, build our program. Okay, oh, sorry. So my error is couldn't find underscore 1 in I32. I think I may have screwed up when I was typing the signature for the C function in Pony. Let's go back here. All right, maybe I don't remember how to do that one. Well, I think we can pass a tuple. Let's do that. And let's make this do something a little different. We're gonna create a new structure that has two values, x and y. We're going to multiply them together. Should be allowed to do this. Obviously, I should practice this a little better. Let's get removed. All right. Well, now I'm feeling like I've screwed something up here. Okay, let's yeah, thanks. Welcome to that didn't work. All right. Instead of getting bogged down in that, let's not worry about this whole alternative struct thing for now. Let's pretend like that was just a fever dream. Used to be able to do something like this. Maybe this got removed, or maybe I'm just doing it wrong. Anyway. Okay. Let's take a look at callbacks real quick. So, I'm calling them callbacks. Really, it's function pointers in Pony. So, what I want is to be able to get a function pointer, a pointer to a function written in Pony that I can call from C. So let's start by creating a C function that takes a function as an argument and calls it. I think I've done that right. No, of course not. Let me see if I can remember how to do this. Oh. Sorry. Okay, there it is. All right, my C is very rusty. Okay, so we can pass a function into this thing, and it will call that function, as long as it's a function that takes no arguments and doesn't return anything. So what we want to do up here in Pony is create a function that we can call from C. And so if we look at the Pony documentation, there's a section called callbacks, which again should probably have a better name, like just function pointers or something like that. But Pony gives you a way to declare what it calls bare functions. And what that means is that you can have a function that is part of a class, but it operates a little differently than a regular Pony function. Basically, it doesn't have a receiver object. And so you can hand it off to C, and C will call it for you appropriately. So we're going to do this, and we're going to create a function called, just call it fn for now. And what do we want to do with this? So let's actually have it return something, and maybe we'll have our C function print out whatever it returns. In this case, we're actually returning an int. Okay. All right, so we're going to do this. And now we want to call it, so we'll call fun. Oh, let's define call fun up here. So it doesn't return anything, so this is none, and it takes one value. And then we're going to say address of has fun fn. So we'll compile, we'll create our archive, and the error was can't find declaration of has fun. Did I call it has fn? With fn. No, it's totally off. Try that one more time. Okay, so that compiles. So we'll expect to be able to run this and see 42. And I believe that's our 42. Yeah, so what happens there is we're passing in a function that we've written here in Pony, and we're calling call fn with that function. So the function hasn't been called yet. We're just getting a pointer to that function. And then in here in the C code, we actually call the function and take the return value of that function and print it out. Let me make this a little more explicit. build it. Now run it. Okay, so here we go. From C42. Now, just so you know, you may be looking at this and thinking, okay, so why does this from pony 20 show up here after from C? It seems out of order because the call that prints this out is actually the last thing in our program. The reason for that is that in the other places we're using inv out print, and out is actually an actor with a behavior called print. And if you remember pony, things about pony, what that means is that print is actually asynchronous. So there's an actor that's handling the job of printing things out that runs asynchronously. So just because we call print here doesn't mean that something will get printed out at that point, at the point when this line of code is run. Something will only be printed out when the out actor gets scheduled and then handles the print message. On the other hand, when we make a call to call fun and then subsequently call our function, that is all handled synchronously. And so when you look at the output, you're actually seeing this line here, that this ended up printing out before this other thing here. So that's why they're out of order. Okay, so that's moderately interesting, depending on your perspective. So just for some background, when we do this, effectively it sets up a different, it tells Pony to build this particular function differently than it would have built it if it had just been a regular Pony function. So Pony functions, when they get compiled down, they end up having an implicit first argument, which is the receiver to the function, basically the object that the method was being called on. And so in this case, we compile the function differently so that the first argument is not a receiver. This makes it so that the first argument is whatever argument you've passed to it. The other thing it does is it changes the way that the function is set up to be called. So there's the C calling convention, and then there's this fast calling convention that LLVM has. And so normally Pony functions use the fast calling convention. And in this case, we say, okay, make this into a function that can be called from C. Use the regular C calling convention. So, you know, if you're somebody who's interested in those kinds of details, now you know a little bit more about these things. So what this means is that within this function here, you can't access any property. You wouldn't be able to access any properties of the class. So let's actually take a look at this real quick. I think we can do this. So this will create a with fn object. And then we should be able to call with fn to get our function that we're calling. And this should still work. now, if we come back up here and we say that our class has a field called x, and we try to access x within this function, we should get an error. Yeah, can't reference this in a bare method. So again, what's happening here is that this is a bare method. It has to be part of something in Pony, but it doesn't actually have access to any of the members of this thing that it's part of. So I think one thing I think we can do, although I've never tried this, we should be able to just say this is a primitive rather than making it a class. And we should be able to do all of this. Anyway, making it a primitive, depending on how you're writing your code, making it a primitive may make it a little more clear that this thing is part of a thing that doesn't have any properties. And just to remind you, in Pony, a primitive is kind of like a singleton object. You end up with an object that only has functions attached to it. That's not I don't remember if that's exactly how it's implemented, but you can kind of think of it that way. There's only going to be one of these things, and there are no properties, so it's basically the other way to think of it is it's a module that just has functions. So I think we should be able to compile this, and this should still work. Yeah. Didn't get any errors, so we'll call that a victory. All right. So one thing that you might be tempted to do is something like this. Instead of having the address of down here, maybe we can just say, hey, we'll get our address, and then we'll call fn, which should be the address of the function. And that's an interesting thought. But if you look at our result here, it says the address of operator can only be used for FFI arguments. So you can't actually call address of outside of an FFI call. So depending on how you're structuring your code, there are things that may be more or less frustrating to have to do because of this. So for example, if you wanted to store that address of your function, you're kind of out of luck. There's just not a good way to do it from Pony. So that's just something to keep in mind. And it's not just with functions, it's with anything. So if you wanted to get an address of a field, like of an integer field or something like that, that you could then pass off to a function, you wouldn't be able to do that either. You'd have to actually call address of as you were calling the function. So but anyway, yeah, this is listed in the documentation, as I said, under a thing called callbacks. So this was originally added to Pony specifically because there were some cases where there were libraries that had callbacks, and so you'd pass a function off, and then the library would call that function after it had done some work, and it would pass that function some data of some kind. And then that function would be responsible for handling that data. So, for example, SQLite has this exec function that takes as one of its arguments a function that is called for each line that is returned by a query. And so using this, you could write a function that was called, you could write a function in Pony that would get called by C, and everything would run appropriately. So bare lambdas are also a thing. So let's see here. So we should be able to call our call fn with a bare lambda, which means that we'd have a function here. Let's just return 56. Okay, and there we go. We've got our from 42, which is from calling that function that we had defined within our primitive. And then we've got this 56, and this is the thing that comes out of our bare lambda. So this thing here is lambda. So if you don't want to stick your function somewhere inside a primitive, you can kind of define it like this. And in this case, we should be able to do this now. So when working with the bare lambda, since we don't have to call address of, we can actually create this thing and stick it here, and it'll work. Yeah, and so the bare lambdas are limited kind of in a similar way to the function. They can't specify captures, they can't use this, and they can't specify a receiver capability. And they always have val capability. So basically they're pure functions. They can only operate on what gets passed into them. Yeah, offhand, I'm not exactly sure what the signature for that even looks like, what the type is for this. I should probably go and investigate that. Anyway, if you scroll down, if you're looking at this, there's an example here of how to use that SQLite function that I had talked about. So you can come and see this, and it's kind of an interesting example of calling C from Pony and then having the C call Pony. And so you're kind of threading back and forth from Pony to C and back to Pony. So that kind of covers it. With what you've seen here, you should be able to get started with doing your own FFI work. And you should be able to do things like send and receive simple types like integers and floats and things like that. You should be able to work with strings and arrays. We looked at that last time. And you should be able to call functions. You should be able to pass function pointers from pony functions, these bare pony functions, into C and have them get called appropriately. So that's kind of the gist of FFI. So I guess there are some things you need to watch out for depending on what you're trying to do. One of the biggest potential issues one of the issues that I've run into that's been something that you have to find a way to work around is if you are using a C library, that expects that your program has control over what thread something runs on, you may run into some issues. So there are, for example, there's the Python library, which lets you interact with Python code via C API. That actually expects to be started up and stopped from the same thread. And because of the way Pony works, you can't really do that. And the reason is that Pony can't guarantee, it tries to run actors on the same thread every time they're run, but that's not guaranteed. If one of the threads doesn't have anything to do, it will try to steal work from one of the other threads. And so you could end up starting the Python interpreter in one thread and then calling the shutdown or the cleanup function from a different thread. And yeah, basically that won't work. Anything that tries to use thread local variables, you may not have problems with, but you will probably have problems with. You can sort of get around this by running your Pony program with a single thread, although that then starts to defeat some of the nice features of Pony, because now you've just got a single threaded program. So that's probably the biggest thing that could come and bite you, is basically if you're working with a library that either tries to manage its own threads or makes some strong assumptions about how the calling program is going to be managing their threads, you need to be aware of that. You may need to look for some ways to work around that. One way could be to spin up your own thread yourself that then starts these other threads. Other than that, the FFI system is pretty straightforward and pretty useful. I think I talked about it a little bit last time. There's not a good way to automatically import like structs and enums and things like that from C into Pony, and so you end up having to write function, or you have to basically construct these things by hand or build tools that parse your code that then generate the appropriate Pony structures for you. So that can be a little bit frustrating, but it's, to be fair to Pony, it's not that different than what a lot of other languages make you do. So I guess that's just to say that everybody's equally bad. So anyway, I think I'll wrap it up here. Next time I will show some examples of using Pony and C together in real-world libraries. My plan was to maybe take a look at Lua and the SQLite libraries and just kind of walk through some examples of writing Pony code that calls into those libraries. So hopefully you'll tune in for that next time, and I'll see you then. Until then, take care.